So I mentioned that I would give you an overview using the sample quiz that we talked about in class today. And here it comes. So we have 16 moles of aluminum selenide in number 1. So you'll take 16.0 moles of aluminum selenide. So the first thing you're going to do in all these problems is write down the number that you're given. So 16 moles, 320 grams, 936 grams, and so on. It says that we have moles of aluminum selenide. So just like when you go to the store and your mom wouldn't send you to the store and say, get a dozen. She'd tell you want to get a dozen of something. So we're going to get a mole of something, but the something is aluminum selenide. So we have to be able to write a chemical formula for aluminum selenide. So we go to the periodic table, and aluminum is here. Selenide, remember the IDE ending means it's not at the bottom down here, but rather up at the top. So all of these guys down here end in ATE down at the bottom, except for a couple of things like hydroxide and cyanide. But the vast majority of these guys down here end in ATE. So when you see IDE, then you think you need to go to the top. So this says IDE, and it's selenide, so that would be selenium. So you look here, and selenium is over here with these possible charges. And the first element was aluminum, which is this. So aluminum selenide will include aluminum and selenium. Now since selenium is further to the right on the periodic table, over here, than aluminum is, selenium will gain electrons. And when it gains electrons, it's going to need to gain 2 to get to 8. Remember, there are 6 in the outer shell, so it's going to gain 2. So of these 3 charges, the one that we're going to be using is -2. All right, so we write our formula for aluminum selenide, AlSe. Aluminum was a +3 charge on the periodic table, where selenium was -2. So here's +3, and selenium we're going to use the -2. All right, so the common multiple of 3 and 2 is 6, so you're going to need 2 atoms of aluminum and 3 atoms of selenium to make the charges equal. Okay, now we're finished with those numbers. We don't even need to write those in, but you have to think about them. All right, we're looking for grams. We have moles. So we need to get rid of moles of aluminum selenide. So we've said in class a lot of times that whatever's here goes down here, not the number, but everything except for the number goes down at the bottom. So we'll put moles of aluminum selenide on the bottom. On the top, you'll put grams of aluminum selenide. 1 goes with moles. And on this quiz, 1 will always go with moles. In the stoichiometry homework that we've done, 1 always goes with moles except in the mole ratio. But on this quiz, there was no mole ratio, so 1's going to always go with moles. All right, to find the formula mass of aluminum selenide, I'm going to go over here and calculate it on this side so as not to confuse it with the problem, but you have to know the number for the mass of this, and that's what goes in that spot right there. So we look at the periodic table again. Aluminum's mass is 26.98, so we would round that off to 27. Selenium's mass is 78.96, we would round that off to 79. So you have 27 and 79. All right, we need to multiply the 27 by 2 because there are 2 of them. We need to multiply the selenium by 3 because there are 3 atoms of selenium. So 79 times 3, you pull out your calculator and go 79 times 3, 237. And 27 times 2 is 54. Then add these together. So 54 plus 237, 291. Then you would multiply 16 by 291. And that is our final answer, because that answer will be divided by 1. Moles cancel, and you're left with grams of aluminum selenide. So we know that Everybody's test has this kind of a question on it, where you're changing moles to grams. The difference is what you have right here, which is going to change this number. The format will be the same. And again, when tying this into the mole map, if you have 16 moles of this, and you want to go to grams, you have to use the formula mass, and that's what this number is, the formula mass. You can't write the formula mass, though, until you know the formula, so we had to figure that out as well. Next question. This time we have 320 grams. So remember, we said the first thing you do is write the number down, and then the unit. It's grams of propene, which is C3H6. Okay, without even looking at the problem, we already know what goes down at the bottom. Remember, everything that's here, except for the number, goes down here. All right, so we're starting with grams, and we're trying to get to molecules. So grams are here, molecules are over here. So we need to go from here all the way across. So think of these little boxes like stepping stones in your backyard. So we have grams here in one stone, we have moles here in another stone, we have molecules over here. So we're going to go from grams to here and then step to this one. So grams to moles will be our first step. So we'll put moles of C3H6 on top. Now once again, we're changing grams of C3H6 to moles of C3H6. What's here goes down here. The number that goes with moles is 1. And it says that when we want to move from grams to moles, we use the formula mass. So we have to figure out what that is. So we have carbon and we have hydrogen. So go over here. Carbon is right here. It's got a mass of 12. And hydrogen's over here has a mass of 1. So I have C3H6. We said carbon was 12, hydrogen was 1. 1 times 6 is 6. 12 times 3 is 36. So 36 and 6 is 42. All right. Now, grams of that is canceled out, and the unit that I have is moles, so I'm right here on this stepping stone, but I still need to go over here. So we know what goes on the bottom. Whatever's here goes on the bottom right there, but not the number, just the words. And on the top, we need molecules. And the number that we use, it's hard to see it on there, I'll show you it down here, is 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd, and that's per 1 mole. Now we're ready to do the math. So we're going to have 320 multiplied by 1 multiplied by 6.02 times 10 to the 23rd. So let's do that. And I'm going to show you on this calculator how to remind you how to type in these numbers. So 320 times 1, which I'm just going to skip that, then multiply by 6.02 times 10 to the 23rd. So times 6.02. Now we do not use the times 10. We use the EXP calculator button on this calculator, but you use the EE key if you're using your iPhone. So EXP, see how it pops two little numbers up there, 23. So that's these two, 23 gets typed in after you hit the EXP. Again, do not hit times 10. Okay, so that gives us what's across the top, and then we divide by every number that we see on the bottom, which in this case is just the 42. So divide by 42, and you end up with 4.59 times 10, and see this little that little 24 right there. See how it's elevated, so that's times 10 to the 24th. And that would be the answer in the second one. All right, third one. Again, you write the number down that you're given. So everybody's test will be kind of framed this way, where you have grams and go to moles. It's going to be a one-step problem. You need to write the chemical formula for aluminum sulfate. So aluminum is Al. sulfate, since it ends in ATE, you're going to look down at the bottom for that one. There's a hydrogen sulfate. There it is, sulfate. It's SO4 with a -2 charge. Remember earlier we looked up aluminum, and its charge was +3. Right here it is, aluminum +3. So you need a common multiple of 2 and 3. So that would be 6. So how many aluminum atoms would you need to make a +6 charge? You need 2. How many sulfate ions do you need to make a -6 charge? -2. But since this is an ion with more than one atom in it, you have to put it in parentheses because we need 3 of those whole groups. All right. We're trying to change it to moles, so we're starting at grams, we're going to moles, and we're stopping, so it's just a one-step problem. We need to find the formula mass. So I'm going to do that over here on the side again. So Al2 SO4 parentheses 3. Okay, Al has a mass of 27. Remember that? And then sulfur, I'm going to write down these numbers while we're here. Sulfur has a mass of 32. Oxygen, a mass of 16. So 27, 32, 16. So now back over here. This is 27. This is 32. This is 16. All right, so now this is going to need to be multiplied by 2 because there are 2 atoms of aluminum. We have to add this in. I'm going to put this in parentheses because the sulfur and the oxygen are in the parentheses. And inside the parentheses there are 4 oxygens. So I only have 1 sulfur, but 4 oxygens. So that has to be multiplied by 4. So you add those together. And then we have to take that answer and multiply by 3. All right, so 27 times 2 is 54 plus, inside the parentheses I have 32 plus 16 times 4. 16 times 4 is 64 plus 32 is 96. So that'll be 96 times 3. Well, 96 times 3 is 288. So this right here is 288. Remember, do you remember you multiply before you add, and then 54 gets added onto that. So 288 and 54 is 12, carry 1's 9, 9 and 5 is 14, carries 342. So that's 342 grams in 1 mole. All right, so over here, I know I'm going to have grams of aluminum sulfate on the bottom because the whatever's here goes on the bottom. And on the top, you're trying to find moles, so put moles of aluminum sulfate on top. 1 goes in moles. We just figured out that 342 goes with the aluminum sulfate, so 936 divided by 342 equals 2.74 moles of aluminum sulfate. All right, that's number 3. Number 4. This time, most quizzes will ask for liters. A couple ask for grams. I'll address that in a second. So if you have 2.44, remember the first thing you do is write the number down, times 10 to the 28th molecules. It doesn't say what the gas is, so I'm just going to write gas. Okay, trying to get to liters. So here are molecules, here are liters. So it's going to be how many steps? You're going to go from here to here, and then from here to here. So 2 steps. All right, so on the bottom, whatever's here, except for the number, goes on the bottom, so we'll have molecules of gas. And on the top, you put what you're looking for. Now you could put liters here, but we're going to go through moles on the way to liters, so we're going to put moles up there, because that's the second step, from here to moles, and moles to liters. 1 goes to the moles, and the number of molecules that are in a mole is this number right here, 6.02 times 10 to the 23rd. That's moles of gas. All right, now you know that moles of gas go on the bottom. And if your test asks you for liters, you're going to put liters on the top. If it asks you for grams, then you have to write the chemical formula and find out how many grams are in that formula, like we did up here. Most of them ask for liters. Okay, so 1 goes in moles. And then in a mole of gas, there are 22.4 liters, using that number there. So now we're going to do the math. You're going to have 2.44. Do I press n times 10? No. You're going to use EE key again. So go down to the EE key, and that little number is going to pop up, and that'll be 28. You're going to multiply that number by 22.4. And then you're going to divide by 6.02 times 10 to the 23rd. And so you end up with 907,907 on this one, or 908,000 if I round off. And the units are liter. Molecules canceled and moles cancel. So again, here's the math. 2.44, then you type in the EXP key, and that was 28. Multiply by 22.4. And then divide by all of the numbers on the bottom, was just that number, 6.02. No times 10, so don't hit times 10, hit the EXP again, 23, and you get that number. Last question. You have 89.6 liters of carbon dioxide. First thing you do, write down the number, then the unit. All right, this says carbon dioxide, so I'm expecting you to know that when you're talking about numbers of atoms using prefixes, mono means 1 atom, di means 2 atoms, tri means 3, tetra means 4, penta means 5. So this is di. So what's it mean? 2. So we have carbon and 2 oxygens. Remember that the little subscript tells you how many atoms. So you have 2 atoms of oxygen. Okay, so we're starting at liters, and we're trying to get to mass. So mass is over here, because mass is measured in grams. So we're going to go up and over. When we're moving from liters to moles, you have to use this number. So I'm going to put liters on the bottom, moles on top. 1 goes in moles, and the number of liters that are in a mole is 22.4. Now we have moles, so we're here, and we want to get over to grams. So on the bottom, remember whatever was here is going to go down here. So we'll put moles of CO2 down there. 1 goes in moles. We have to find the formula mass of carbon dioxide. Carbon is 12, oxygen is 16. We know that because we know our periodic table. There's 12, there's 16. But there are 2 oxygens, so that has to be multiplied by 2. So now I've got 12 plus 16 times 2. In order of operations from your math class, you're going to do the multiplication first, so that's 32 plus 12 is 44. So that number will be 44. So now we have 89.6 multiplied by 44, and divide that answer by 22.4, and we get 176. And that is how you do that test. So again, the tests are basically the same in terms of format, but the things you're dealing with are different. So you need to be sure that you write your formulas correctly, and so that you find your formula masses correctly. All right, there we go. Hope that helped.